Yeah.
Hi, I'm Nabiha Mohammadi, and our group member 7 decided to study the impacts of natural calamities on the employment sector. The purpose of our research was to predict the effects of natural calamities such as hurricanes on employment sector of the United States. We've noticed that disasters have caused massive short-term disruptions to the economy and labor market, especially in the construction industry, but the long-term impacts still remain unclear. The prediction of construction employment is important to balance the requirements of demand and supply. Our study will help to prevent understaffing and overstaffing during disasters and help to find an equilibrium between the demand of labor and its supply. We previously collected the employment data of different sectors from United States Bureau of Labor Statistics for about 12 years, and we made another data set of Hurricane Harvey and Ida. In an attempt to get precise results, we are focusing on major metropolitan areas that were affected by these calamities. We collected the affected area and dates of these hurricanes from the trajectory. By using machine learning techniques as a tool, we are forecasting patterns of employment to minimize the effect on employment of such calamities in the future.
Hi everyone, this is Aditi. I'm going to be talking about the data sets that we used. The data sets which we are using are collected from the US Bureau of Labor Statistics. The target is employment data which spans from January 2011 to April 2021. There are 11 categories which we are considering, including total non farm, mining, logging and construction, manufacturing, trade, transportation and utilities, information, financial activities, professional and business services, education and health services, leisure and hospitality, and government. So, for Hurricane Harvey, we collected the data by analyzing the trajectory of the hurricane and which all states were damaged because of it. Based on this, we found that Hurricane Harvey affected 3 states, 20 metropolitan areas, and 32 counties. Similarly, for Hurricane Ida, we followed the same methodology. We traced the hurricane's trajectory and determined the data set, and we found that Hurricane Ida affected 8 states, 34 metropolitan areas, and 37 counties.
Hi everyone, this is Hannah. So, talking about the methodology, we are following the predictive analysis method, which is an advanced analytics that uses new and historical data to forecast activity behavior and trends. So, in our study, we were able to develop a projection of how hurricanes affected employment by understanding the trends and patterns to the data we collected. So, first, we identified the data we needed, then we collected it, we cleaned and pre-processed it for the analysis. So the data we have is continuous. So we are using regression models for our analysis. So from the analysis, we are getting results and we are going to interpret it. So this is very useful for forecasting and predicting outcomes from data, since the approach predicts a continuous outcomes. So the target and features of our model. Our target is the employment data from 2011 to 2022. So for the features, we defined 5 factors that will affect the employment rate. These are population, GDP growth, GDP, inflation, and gas price. So to increase the accuracy of our model, we converted categorical variables into dummy variables like months, years, and areas. So we collected data of these 5 features from the years of 2011 to 2021. So further on, this data was utilized in machine learning to code our models. So these are the visualizations of our features and the target. On the left side, you can see the features patterns like population, inflation, GDP, and gas price over the past 10 to 12 years. And right side is the data visualization of our target, which is the employment, depicting different sectors of the employment. So the process of regression models. Regression is a method of determining how independent features or variables relate to a dependent feature or result. The regression models are trained to understand the relationship between different independent variables and outcomes. So as a result, The model is able to comprehend the numerous aspects that could result in the desired conclusion. So it is a technique for machine learning predictive modeling where an algorithm is used to forecast continuous outcomes. So the first one is the linear regression analysis. So this is the easiest and most widely used method for forecasting a continuous variable. It presupposes that the connection between the predicted variables and the outcome is linear. The positive coefficient, which indicates that as the value of the independent variable increases, the mean of the dependent variable also tends to increase. A negative coefficient suggests that as the independent variable increases, the dependent variable tends to decrease. So for our linear regression model, we have an accuracy of 76%. The next one we have is the decision tree regression analysis. This can be used to perform non-linear regression in machine learning. So the values of all the data points that relate to the problem statements are plotted using the subsets of the dataset. This algorithm divides the data into decision and leaf nodes, producing a decision tree. The goal of using a decision tree is to create a training model that can be used to predict class or the value of the target variable, which in this case is employment. So by using simple decision rules inferred from the prior data that we have. So for our decision tree regression model, we have an accuracy of 69%.
For our neural regression analysis, the neural regression is a supervised learning technique that needs a labeled data set with a labeled column. The labeled column needs to be a numerical data type since the regression model predicts a numerical value. We are providing the model and the tag dataset to train the model as inputs to get an accurate result. The values for the new input can be predicted using the trained model. The R2 score for the neural regression model for our employment dataset is 99%. The random forest regression analysis is a supervised learning algorithm that utilizes ensemble learning approach for regression. The ensemble learning method combines predictions from various machine learning algorithms to provide predictions that are more accurate than those from a single model. The random forest is a group of many trees, each trained on a different subset of data points and features, which each individual tree is different from others to gather unique relations from the dataset. The random forest model accuracy for us is 52%.
So in conclusion, we analyzed the impact of hurricanes by generating machine learning models. Our interpretation is that hurricanes does have an impact on the employment in the tech sectors like trade, transportation, utilities, information, and government. In the case of linear regression model, we have an accuracy of 76%. For the decision tree, we have an accuracy of 69%. And for the random forest model, we have an accuracy of 52%. It is suggested to expand the study to further subjects such as damages of residential buildings in hurricanes and narrow down the scope of the study to specific types of houses. So the next area we can explore is the impact of hurricanes on the commitment of crimes or etc. So by using the same methodology and by expanded programming, we can achieve interesting results in this study. Thank you.